Hi, welcome back to Moose and Chemistry. Today we're going to do our VSEPR Models Lesson 2. Today we're going to work on, first compound is Boron Tri Hydride. Now Boron Tri Hydride, boron is in group 13, remember, so it has 3 valence electrons, so there are valence electrons there. Hydrogen is in group 1 and it only has 1 valence electron. So remember that if it has like a 13, 14, whatever, you take out the 1 and that gives you the 3. So now let's figure out the total number of valence electrons in our structure. So we have 1 boron atom with 3 valence electrons. We have 3 hydrogen atoms, each with 1 valence electron. So now when we add this up, we have 3 electrons here, and we have 3 electrons here. This gives us a total of 6 valence electrons. So we're going to put boron in our center because, a couple of reasons why, because it's least electronegative, plus it has 3 docking ports. So we're going to put H, H, and H. We'll space them out. 2, 4, 6 electrons. So now we've used up all our electrons. But let's see if this is the best possible structure for boron trihydride. So we're going to do something called formal charge. So we take our formal charge of boron, which equals valence electrons minus non-bonding electrons minus bonding electron pairs. So now boron comes in with 3 electrons. It has 0 non-bonding electrons because they're all bonded, and we have 3 bonding pair. This gives us a total of 0, which is good, because remember, the closer to 0 we are, the better off we are. So let's check out the hydrogens. Now we don't have to do all the hydrogen formal charges because they all look the same. So we do valence electrons again, minus non-bonding electrons, minus bonding electron pairs. So now if we look at hydrogen, hydrogen comes in with 1 valence electrons. All the electrons are being bonded, so we have 0 non-bonding electrons and we have 1 bonding pair, which we can see right there. So go ahead and do that real quickly. And that gives us a total of 0 also. So this is the best possible structure. Now, what kind of VSEPR model is it? So our core atom we label as A, and our wraparound atoms get X's. And we have no unshared pair electrons left over, so this is called an AX3, which we call a trigonal planar. The bond angles on the trigonal planar are all at 120 degrees. So each of these angles are 120 degrees. Now, let's look at another one. So let's go ahead and clear all these drawings. So we're going to clear all the drawings first here and clear them. And our next one is going to be called silicon disulfide. Silicon disulfide, which is written as SiS2. Silicon is in group 14, so it comes in with 4 valence electrons. Sulfur is in group 16, so it comes in with 6 valence electrons. Again, remember, take out the 1s on either of those numbers, and that gives you an easy way of figuring out how many valence electrons does it have. Sulfur has 4 docking ports, 1, 2, 3, 4, and silicon has 4 docking ports, and sulfur only has 2. So we're going to put silicon in the center and put an S on either side. So let's use up our electrons after we figure out how many we have. So silicon has 1 times 4 electrons, and sulfur has 2 times 6 electrons. This gives me 12 electrons, and this gives me 4 electrons, which gives me a total of 16 valence electrons that we have to use up. So let's go first 2, 4, 6, 8, 10, 12, 14, 16. So we just drew a structure. And so let's find out if this is the best possible structure. So again, we're going to use formal charge of silicon. which is valence electrons minus non-bonding electrons minus bonding electron pairs. So silicon comes in with 4 valence electrons. They're all being used, so we don't have any of that. And we count our sticks. There's 1, 2, 3, 4 sticks. So we're going to ahead and back that off there. And that means there are 4, so that gives me 0. That's good. Let's check out the sulfurs. Both the sulfurs look the same, so we can just do one of them. So valence electron here minus non-bonding electrons again minus bonding electron pairs. So sulfur comes in with a total of 6 valence electrons. Non-bonding electrons, we have 1, 2 of those. So we're going to put those 2 pairs in, so that gives us 4 non-bonding electrons. And our bonding pairs, there are 1 and 2. So get rid of that. So this is going to be 6 minus 4 minus 2, which is 0, which is also good. So go ahead and erase that stray mark there. Not sure how it got there, but we get rid of it. All right. So now, let's look at another one. All right, instead of doing another one, we'll just define what VSEPR is. VSEPR, the main idea is that electrons don't like to hang around each other because they repel each other. As a result, the atoms in a molecule tend to separate as far as they can because their bonds repel each other. And this is another amazing day with Moose and Chemistry, and I'll see you back on the next lesson. Have an awesome day.